one of the many uses of trigonometry is finding missing distances or lengths. And that's what we're going to do here today. We're going to use sine, cosine, and tangent to find the missing lengths of sides of a right triangle. So here are the steps. Here's what we're going to be doing. The first thing you've got to do is you have to find your reference angle. So the reference angle is just the angle that you know, the angle that you're working from. So and if you see the little picture on the upper right here, your reference angle is down here at point Q. Then you want to identify which side you're looking for and which side you already know. So chances are there will be one of the three sides, the opposite, the adjacent, or the hypotenuse, that will have a variable on it, like an x or y, or just from the context of the problem, you'll know you are looking for that side. You're trying to figure out what that side is. Then you'll also have a side. To be able to do this, you have to have some information going into it. So you have to have one side that you already know. And that could be, again, the opposite, the adjacent, or the hypotenuse. So you're going to find the side you already know, find the side you're looking for. And then using that, you're going to decide, do I need to use sine, cosine, or tangent? And we're going to go through some examples where you can see how this works. But for example, say that the side you already know is the opposite side on the triangle. And say the side that you're trying to figure out, the side that you're looking for, is the hypotenuse. Well, then you would want to use sine because sine involves the opposite and the hypotenuse. Say you are looking for the adjacent side and you already know the length of the hypotenuse. Well, in that case, you would want to use the cosine. So you're going to figure out which of the three you're going to use based on the sides you're working with. Number 4 is really important. You're going to use a calculator to work these out. And make sure your calculator is set to degrees. Every angle can be measured in degrees, but it can also be measured in what are called radians, which is something you'll get into when you get into Algebra 2 and pre-cal. You'll learn all about radians. And radians definitely have their purpose, but for what we're doing in this class this year, we're using degrees. So you need to make sure your calculator is set appropriately. And I will, if you want to use the Google calculator, I'll show you how to make sure that's set on degrees. And then I'll post a video if you're, say, using a graphing calculator like a TI Inspire. And then you're going to use a calculator to figure out the sine, the cosine, or the tangent of the angle you're working with, and then solve the equation. So let's actually see how this works, because I think it'll make more sense when you have an example to look at. So here's the first example. It says to find the value of x. So I'm looking at my triangle. I've got this angle right here that is 36 degrees. That's the angle I'm working with. That's my reference angle. So I want to label my sides. I know the 7 is the hypotenuse. If I go across to the opposite side, it's this side over here on the right that is not labeled. And so x is my adjacent side. So when I look at the side I know already, that's the 7. And the side that I'm trying to figure out, that's the x. I know that I'm dealing with the hypotenuse and the adjacent. So if I think about my acronym, SOHCAHTOA, I know hypotenuse and adjacent uses the cosine. Cosine is equal to the adjacent over the hypotenuse. So now I want to set up that equation. I want to say cosine of my angle, because whenever you do sine, cosine, or tangent, it's always the sine, the cosine, or the tangent of an angle. You have to have an angle you're working with, and here it's 36 degrees. So I'm going to say cosine of 36 equals, and then it's AH, adjacent over hypotenuse. So that's going to be x over 7. Now, to work this out, this works out pretty nicely because our goal is to get x by itself. And right now, we just have x divided by 7. So to work this out, we just needed to multiply both sides by 7. So we can cancel out that 7 that's underneath the x. So x is going to be equal to 7 times the cosine of 36. Like I said, you will need a calculator for this. So I'm going to go over to the Google calculator. And what I want to show you here is in the upper left-hand corner, you'll see it says rad and dig or deg, but that stands for radians and degrees. And you want to click on this button so that degrees is in black and then radians is in gray. You want degree to be highlighted in black there. Otherwise, if you don't do that, you're going to get the incorrect answer. So my equation I was 7 times the cosine, and you'll see that little button for cosine there, of 36. And so I'm just going to put that in the calculator, and I'm going to get something where I have to round off. I'm going to round this off to the nearest hundredth, so 2 places after the decimal, just to be as accurate as possible. But this is going to be 5.66. So my answer here, rounded off to the nearest hundredth, would be 5.66. That's it. And again, always check to make sure your answer is realistic. I know on this triangle, 7 is my hypotenuse. So 7 is the longest side. So I'm looking for a number. It's got to be smaller than 7. And 5.66 seems pretty reasonable for the triangle that we're working with. It makes a lot of sense to me that like the length of x would be a little bit bigger than like 5.5. So that's how these work. But there are some variations. So we're going to do some more examples here. So here it says find the length of the hypotenuse. So we don't have a variable on the diagram right now, but it says hypotenuse. And I know my hypotenuse is the side that's opposite the right angle. So it's going to be side CA here. So that's what I'm looking for, is that side. So now I want to figure out what other side I'm dealing with. So x is the hypotenuse. This is my reference angle right here. It's the 52. The 12 is opposite the 52. It's across from the 52 on the other side. So 12 is the opposite. So what I'm dealing with here is I have the opposite side that I know already, and I have the hypotenuse that I'm looking for. So what I'm going to be using is sine. Sine uses the opposite and the hypotenuse. So now I'm going to set this up. Sine of 52 equals the opposite, which is 12, over the hypotenuse, which I don't know, which is x. Now, this is a little more complicated because the x is on the bottom. So there are some shortcut ways to do this, but I'm going to go through it step by step so you can see what's happening. You don't want x on the bottom of a fraction. So the first thing I would do is multiply both sides of the equation by x. So you're going to have x times sine of 52 equals 12 over x times x. So I multiplied an x on both sides. What that does is it cancels out the x's. And so now what you have is x times the sine of 52 equals 12. To get x by itself, we need to get rid of the sine of 52, so we're going to divide by that. So we're going to divide by sine of 52. And we're going to do that on both sides. And just make sure you are multiplying, dividing, whatever you're doing by sine of 52 and not by just 52. That sine of 52 is a number in itself, and make sure you're using the whole thing. So x now is equal to 12 divided by the sine of 52. So again, I'm going to switch over to the Google calculator and work that out. So I have 12 divided by the sine of 52. Again, I make sure it's on degrees, and it's still on degrees, and I'm going to round to the nearest hundredth. So that's 15.228. I'm going to round that to 15.23. So x is equal to 15.23 approximately. X is my hypotenuse. I know the hypotenuse is the biggest side of the triangle. So I am looking for an answer that's bigger than 12. So that checks out. So always look for those things after you finish the problem to make sure your answer's in the right ballpark. Okay, so we've seen a couple different ways that these can end up working out. We're going to do 2 more. Here it says find the length of AC. Again, the variable is not on the picture. We're going to have to put that in. but it tells us we're looking for AC. That's down here. Our reference angle is here at 40. 32 is the opposite side from 40. And then we don't have anything on the hypotenuse. We're not using the hypotenuse. So the only other side we have is the adjacent. So X is the adjacent side. So this time we're dealing with opposite and adjacent. So that is tangent. Tangent is opposite over adjacent. So now we can set it up. Tangent of 40 degrees equals opposite, which is 32, over the adjacent, which is what we're looking for, and that's X. So just like before, I'm going to multiply both sides by X. The X's will cancel out on the right side. And then what I will need to do is divide by the tangent of 40 to get X by itself. So I will do that. And what I want you to notice here, because this could be a shortcut for you, is that whenever X is on the bottom, whenever the variable is on the bottom and you start to work these out, what you're always going to end up with is your other side, the side that you know, divided by your sine, your cosine, or your tangent. So here we end up with 32 divided by sine of 40. On the last one, we ended up with, I think, 12 divided by the sine of 52. So when X is on the bottom, you end up dividing. When X is on the top, you always end up multiplying. So that's just something to keep in mind that might save you some time. So let's plug this into the calculator. 32 divided by tangent of 40. And we get approximately 38 point, we got 136. Again, I'm rounding to the nearest hundredth, so that 6 is going to bump the 3 up to a 4. So we have 38.14. And again, since we look at the side we already know, that's 32. So it seems reasonable, and I already forgot my number. It's 38.14, I'm sorry. 38.14. That seems pretty reasonable if the other side's 32. All right, one more. So we've done one sine, one cosine, one tangent. Let's look at this one, see which one we're going to use. We've got the variable, we have X on the picture. We're using this 28 degree angle as our reference angle. I want to identify my hypotenuse since this is turned a little funny. So the hypotenuse is going to be down here because it's across from the right angle. That's the side we're not using. So then X is going to be the opposite side. It's across from the 28. And then the 11 is the only other side we've got. That's got to be the adjacent. So once again, we're using tangent, opposite over adjacent. So I'm going to take tangent of 28 equals the opposite, which is X, over the adjacent, which is 11. This is another one like the first one we did where the X is on top. So we end up multiplying. And all we really need to do to work this out is multiply both sides by 11. So we have 11 times the tangent of 28 equals, and then what happens when we multiply by 11 on the right is the 11s cancel out and we just have X. So we just need to type this into the calculator. 11 times the tangent of 28. And it's approximately 5.85. Again, we're going to round up that second digit because the next number is an 8. So 5.85. So I think what you'll find on these is that the trick is getting them set up. Once you get them set up, then it's just about plugging stuff into the calculator. So that is how we can use sine, cosine, and tangent to find the missing length of a side of a right triangle.